Hi everyone, this is kind of going to be a bit of a longer video because there's a lot to cover here before we can understand fully what exactly I'm talking about. So first we're going to cover the structure of the atom. I'm going to use hydrogen here as an example. So, hydrogen, simple atom, is just one proton and an electron. Now, I know this because if I look at the periodic table, there's a 1 right here as the atomic number. Now the atomic number, proton number, and electron number are all the same and always will be. So helium has 2 protons and electrons, neon has 10 protons and electrons, selenium has 34 electrons and protons, and so on, just going down. And when drawing these, you can do it differently. A valence electron can be represented by doing this. You draw the element's chemical symbol, and then how many valence electrons it has. In this case, hydrogen has 1, so it has 1 dot. This is what is called the electron dot diagram. And this diagram is used for simplicity's sake, when you don't feel like, screwing with, drawing the actual atom and all of its protons and stuff. And so next, as I'm looking here at my notes and stuff, I'm going to cover the box. So, on most periodic tables, you'll see this big number, the chemical symbol, the letters, and then the atomic number, which would usually be down here. The atomic number is the number of protons that said electron or atom has. The chemical symbol is what element it is, and the atomic number is the amount of protons and neutrons added up. And each proton and neutron weighs about 1 AMU, which is an atomic mass unit. It's kind of stupid in my opinion, but that's besides the point. So let's say I wanted to draw helium. So helium would have 2 protons and a neutron, because it has to have 2 protons, and the neutron is just there. I'm looking at my notes here, give me a second. Atomic number of 9 and mass of 19. Okay, yeah, so normal occasions, I do believe there would be 1 more proton than neutron. That's cool. Let's see, lithium has 3 protons, beryllium has 4, boron has 5, carbon has 6, and so on. Now, next, I'm going to cover the energy levels. Now, different energy levels go first level, second level, third level. First level can hold 2 electrons, the second can hold 8, the third can hold 18, and then the fourth can hold 32, and that's basically all you need to know. But essentially, the electrons on the outer shell are what are called valence electrons. Now, valence electrons can be found on the periodic table fairly easily by just looking at the group number. Like this entire group, the alkali earth metals, has 1 electron, or 1 valence electron. The second group, the alkaline earth metals, have 2 valence electrons. Third group has 3, so on and so forth. It's a long pattern. So next we're going to cover isotopes. An isotope is essentially just the element with a couple of extra neutrons or a couple less. Like you got chlorine with its normal neutron count of 18, and the chlorine 37, an isotope of chlorine, has 20 neutrons. Now you can find neutron number by taking, or by subtracting the atomic number from the mass number. So we got lithium, which should have a mass of like 5. So you just do 5 minus 3, and boom, you get 2 neutrons. So next, we're going to cover the periodic table and what all these numbers are. So these are group numbers, these are row numbers, these numbers represent valence electrons, as I previously stated, and then the groups are the alkali earth metals in the first group with 1 valence electron, and in the second group you got the alkaline earth metals with 2 valence electrons, and then ranging from rows 3 to 12 or 13, depending on how you want it, you have the transition metals with their various valence electrons. Now, an atom can have no more than 8 valence electrons. You might be wondering, oh, well, how do these numbers work then? Well, it's simple. You just subtract 10 off of it, except for 9. I don't know about 9. But, so this row would have 0 valence electrons, so on most occasions, I do believe, something like that. This row, group number 11 would have 1, 12 would have 2, so on and so forth. The next group, represented by, well, most periodic tables, what would be a black line separating it from the transition metals, are what are called the metalloids, and it's these 7 elements: boron, silicon, germanium, arsenic, antimony, tellurium, and astatine. So our next group is the non-metals. Now, these are all gases, I do believe, and they are the one thing that turn things into covalent bonds, if you saw that video. Now, hydrogen is in group 1 because it has 1 proton. Like all these groups, they're organized because these elements in the groups have similar properties. Like the alkali earth metals all react explosively, and hydrogen is a non-metal, but it's also an alkali earth metal. That's because it has 1 valence electron, so it will react explosively. But it is a gas, so technically it belongs over here, but you can't put it under these groups because that wouldn't make any sense. So, the group number wouldn't be able to apply to it, and it would just screw everything up and make things more complicated. So our next group is the noble gases. Now the noble gases are called noble gases because they don't like to react. And that's because they have a full outer shell with 8 valence electrons. Like we'll take neon for example. This is its electron dot diagram. It has 8 valence electrons. So if hydrogen tries to bond with it, doesn't want that electron, so it just goes back, essentially. Now, group 1 elements and group 17 elements react explosively with each other. Group 2 and 16 react explosively with each other, so on and so forth, just pairing them up. Because until it gets to 5, then it's kind of, it either wants to lose the 5 or gain, or 4, and it either wants to lose 4 or gain 4. So the next thing we'll get to is the Lanthanide series and the actinide series. Now this first row are what are called the Lanthanide series, or in what is called the Lanthanide series, but their entire group name is also known as the Lanthanides. Now the second group is the actinide series, and just like the Lanthanides, could be called actinides. Another thing is that any number, or any atom or element with an atomic number greater than 83, so after bismuth, is considered radioactive. So everything past 83, and the next thing we will cover are the proper, oh, I forgot a group. So these ones down here after 109, most periodic tables, I do believe, either cut it off here or here, because these elements are what are called synthetic elements because they are made in a lab. These are not naturally occurring elements. Us humans have made them. And I do believe that is pretty much all to cover, considering the periodic table, the boxes and what they mean. And I'll throw a little bonus thing in here. Maybe you might want to pay attention or not. But there is another thing called oxidation number, which I won't try to get too in depth. It's essentially the charge of the atom when it bonds. Like say lithium and fluorine bonded. Lithium would have a charge of +1, fluorine atom would have a charge of -1. and those would be their oxidation numbers. That's the charge of the ion.